All right. So I wanted to help you out with number 10. Let's see here. We're talking about an object thrown downwards with initial speed of 20 meters per second, and it falls 300 meters. Okay? So I'm just going to focus on the graphs right now. And I'm just going to focus on your velocity, time, and your acceleration time graph. I'm going to make down positive. So basically my number line is pointing down. I'm going to call it Y because now it's in the up-down direction. And my object is thrown down with an initial velocity and then speeds up as it falls, right? And each second it's going to go further. And I'm going to start my object at 0 meter position. Now, the velocity starts at 20, and then it should speed up. So the graph will look like that. I don't know my time, so I'm going to call that T for time. Time is measured in seconds, velocity meters per second, acceleration meters per second squared, and time in seconds. My acceleration graph looks no different than any other in this section of the class. Acceleration due to gravity is 10 meters per second squared down, and since I made down positive, I have positive acceleration. Now this area of my acceleration graph, and again I don't know time, so my change in velocity must be 10 times t, okay? Now, my displacement is the area of this rectangle plus the area of this triangle here, okay? Now, I know my change in velocity is 10t, so that means this distance, the height of that triangle, is actually 10 times t, right? So that means the area of this triangle here is going to be 1/2. 10t is the height of that triangle, and t is the base of that triangle. Now, the area of this rectangle is going to be 20t, okay? I will have to add those together. I'll have to add this and this for my full displacement. So my displacement is 20t plus 5t squared. Okay? So, let's see here. And I know from the problem that my displacement is 300 meters. So 300 meters has to equal 20t plus 5t squared. Now I'm going to rearrange this to make it look pretty. I got 5t squared plus 20t minus 300 equals 0. I arranged it in descending order, meaning the square, t squared, t to the first power, and then there's no term, t term there. And if I divide all my terms by 5, see right here, I just divide everything by 5, I can simplify my equation to t squared plus 4t minus 60 equals 0. Let me write that on a new page. So that's t squared, let me check what it is again, plus 4t minus 60 equals 0. Okay? Now, at this point, I hope you realize this is a quadratic equation. So we're going to have two solutions because we have a square there. And I don't want to go through the pain of the quadratic equation yet. So I'm just going to suggest that this is factorable. And one approach to factoring is first figuring out your factors for 60, 2 and 30, 2 and 15, 3 and 5. And I want to figure out a combination of numbers where when I need one of them being positive, one of them being negative. So I need factors of 60 that when added will give me 4t, when multiplied will give me negative 60. Okay? So let me think about that for a minute. 3 times 2 is 6, right? And 5 times 2 is 10. So 6 and 10, when multiplied, will give me 60. When added, if I make 6 negative, they'll give me negative 60 when multiplied. So these two numbers, when added, will give me positive 4. When multiplied, will give me negative 60. So this looks good. So I'm going to say minus 6, positive 10. And what this means now is my t plus 10 equals 0 is a possible solution. Or, see, one of these factors, either this factor or this factor, has to be equal to 0. So t plus 10 has to equal 0, or t minus 6 has to equal 0. Well, this one's going to give me a negative time of 10 seconds, which doesn't make sense to us. So our solution is going to be time is 6 seconds, and that's how long it takes our object to travel 300 meters. And now we can find our change in velocity, which is going to be 10 times 6, which is going to be 60 meters per second, which means our final velocity, so if our change in velocity is 60, our final velocity, if I add 60 here, our final velocity must be 80 meters per second. So that was a pretty interesting problem, and I hope that helps. Again, I found the final velocity after falling 300 meters. I found the change in velocity while it's falling, and I found the time it takes to fall 300 meters, which turned out to be 6 seconds. Hope that helps you out. Thanks for watching, and I hope you have a good day.